Lesson 3.3, Understand Proportional Relationships, Equivalent Ratios. In this lesson, we're going to be testing for equivalent ratios to decide whether quantities are in what we call a proportional relationship. The essential question for this lesson says, how are proportional quantities described by equivalent ratios? Example 1 asks us to recognize a proportional relationship. On Sarah's favorite mobile game, she is awarded game lives when she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? Explain. Well, take a look at those 3 screenshots. You can make a ratio to describe the coins found and the game lives awarded. So the first step is to write ratios that relate the gold coins and the game lives. On the first screen, you can see that she was awarded 3 coins and she was awarded a total of 9 game lives. So that ratio is 3 to 9. On the second screen, she was awarded 2 coins and had 6 game lives. So that ratio is 2 to 6. And on the last screen, you can see that she found 5 coins and was awarded a total of 15 game lives. So we can use a table, a ratio table, to determine whether the ratios are equivalent. And again, those ratios were 3 to 9, 2 to 6, and 5 to 15. Each of those ratios is equivalent to the ratio 1 to 3. In other words, for each gold coin that she found, she was awarded 3 game lives. We say that these 2 quantities are in what we call a proportional relationship if all of the ratios that relate the quantities are equivalent. Since each ratio of coins to game lives is equivalent to the ratio 1 to 3, the number of game lives awarded is proportional to the number of gold coins found. In other words, for each gold coin, Sarah was awarded 3 of those game lives. Now look down at the try it question. Miles records the time it takes to download a variety of file types. How is the download time related to the file size? Explain. In looking at each of the types of media, documents, songs, and videos, we have data to show the file size, that's in megabytes, and the download time in seconds. And in order to create the ratios, we're going to compare the download time to the file size. So in the first type of media, document, we're comparing the download time of 25 to the file size, which is 1 and 25/100ths. And we're going to divide those to see that that ratio is equivalent to 20 over 1, or just plain old 20. Do the same thing with the songs. The songs had a file size of 3 and 6/10 and a download time of 72 seconds. So the ratio is 72 compared to 3 and 6/10. Again, that ratio is equal to 20 over 1, or just 20. And last, we look at videos. The videos have a file size of 6 and 25/100ths compared to the download time of 125 seconds. And when you divide those, you guessed it, that unit rate is also 20 to 1, or just 20. So what we can say here is that the ratios for each pair of data are equivalent or equal. So the download time and the file size are proportional. Convince me. How can you show that 2 quantities have a proportional relationship? Well, you can prove that all the ratios relating the quantities are equal. And as long as you can show that those ratios are all equal, then you have proven that you have a proportional relationship. Next, let's take a look at example 2. Example 2. Decide whether quantities are proportional. Is the relationship between the area and the side length of the squares proportional? Explain your reasoning. So the first step here is to make a table to organize the data. Then find the ratio of area to side length for each data pair. So they're labeling the side length as X, and they're calling the area Y. Remember, the area of a square is side times side. So in other words, I'm going to take the side length times itself to get the area. So 2 squared equals 4, 3 squared equals 9, and 4 squared equals 16. So the ratio of the area to the side length is 4 to 2, 9 to 3, and 16 to 4. But are these ratios here equivalent to each other? And the answer is no. So we compare the ratios by finding those unit rates, or how much out of 1. And when we compare those unit rates, we see that they are not equal. And because those ratios are not equivalent, the relationship between the area and side lengths is not proportional. Now complete the try it. Take a look at the table, read through the question carefully, and compare the perimeter and the side length of the hexagons. In case you need a little reminder, a hexagon is a shape with 6 sides. Come back and check your answer when you think you know. Since perimeter is the distance around a figure, and on a regular hexagon, each side is the same length, then to find the perimeter on a hexagon, you can take 6 times the side length to get that perimeter. So when the side length is 2, 6 times 2 makes 12. When the side length is 3, 6 times 3 makes a perimeter of 18. When you compare those two ratios, 12 to 2 and 18 to 3, you get a ratio of 6 to 1. And since the ratios are equal to the unit rate 6 to 1, the relationship between perimeter and side length is, in fact, proportional. Example 3. Use proportions to solve problems. A proportion is an equation that represents equal ratios. Use the table at the right. How many times will a hummingbird beat its wings in 60 seconds? So take a look at the table. We have seconds at 2, 7, and 10, and we have wing beats at 160, 560, and 800. So the first thing that we have to do in step 1 is to verify that the quantities are in fact proportional. In other words, we need to verify that this relationship is consistent all the way through. So when I compare those ratios, 160 wing beats in 2 seconds, 570 wing beats in 7 seconds, and 800 wing beats in 10 seconds, we get a common unit rate of 80 to 1, meaning that a hummingbird beats its wings in 80 times in 1 second. That's the unit rate. Now we can use that information to set up an equation to solve another problem. In other words, we're going to have the wing beats as the top number, and we're going to have the seconds as the bottom number. So that unit rate of 80 to 1 is going to be equal to how many wing beats in 60 seconds. So we're going to solve this as a division equation, because y is being divided by 60. And how do I solve a division equation? I have to multiply both sides by 60 to get the y number by itself. So those 60s cancel each other out, and then I get 80 over 1 times 60, which is 4,800. So a hummingbird beats its wings 4,800 times in 60 seconds. Now let's look at the try it. Ginny's favorite cookie recipe requires 1 1/2 cups of sugar to make 24 cookies. How much sugar does Ginny need to make 36 of these cookies? Well, we can set up an equation like we did in example 3 in order to solve this. We already know that Ginny is going to need 1 1/2 cups of sugar, and that's to make 24 cookies. So the question is, how many cookies will she need how many cups of sugar will she need to make 36 of these cookies? So in order to solve this equation, which is division, by the way, because we see the y divided by 36, we're going to multiply both sides by 36. Now, in order to do that, okay, remember you've got a fraction here. You need to change that fraction into that mixed number into an improper fraction. So then you'll be doing 36 times 3/2, and then there's the 24 on the bottom. So let me get rid of that. There we go. All right, and 36 times 3 is 108, divided by 2 is still on the top, and the 24 is still on the bottom. So when I do 108 divided by 2, I get 54, and then I'm going to do 54 divided by 24, and I get 2 2500ths. Well, when we're doing cooking, we don't ever use decimals, okay? Especially when we're talking about cups. We change that back into its fraction form. So hopefully you recognize 2500ths as being the same as 1/4. So that would be 2 1/4 cups of sugar. To summarize in the key concept, what we need to remember is that when we have two quantities in a proportional relationship, what it means is all the ratios that relate them are equivalent, and that a proportion is an equation that states that those ratios are equivalent. And as you're comparing these ratios, make sure that you're always comparing the y number to the x number. If you're not sure, go to the question itself, okay, especially if it doesn't have a table that is labeled, and look to see which quantity comes first and which quantity comes second. And then ask yourself, what am I trying to do if I need to find the unit rate? Because the unit rate is an easy way for us to make that comparison between those ratios to see if they are indeed equivalent. Always put the unit rate in the form of something compared to 1, and you would want to make sure that the number that you're looking to make into one whole is the bottom number in that ratio. Now I'd like for you to try these problems on your own and come back and check your work when you're finished. Make corrections as needed. Remember, anything that goes in your book should be correct, so make sure that you fix that. And make sure that you put a star or a little sign next to it if you didn't understand it or understand how I got that answer, so you can be sure to ask about that when you have the chance. So the questions you're going to complete from this lesson are numbers 4 and 5, 7, 10 through 13, and number 15. Pause the video while you try these questions and then come back and check your answers. Number 4 is not a proportional relationship. When you look at the ratios of y to x in the table, you get all equivalent ratios except for the last one. And since all the ratios from the table are not equivalent, then that means you do not have a proportional relationship. Number 5. In this question, the relationship between perimeter and side length is proportional. Each of those ratios is equal to the unit rate of 3:1, which means you do have a proportional relationship between perimeter and side length. Number 7. Since they tell us in this question that the amount of seed used and the area of the lawn are in a proportional relationship, then we're just going to prove that by completing the table. For questions 10 and 11, make sure that you find if there is a proportional relationship first. If there is a proportional relationship, then you do have a value of x that you are given and you're asked to solve for y. However, it's not necessary to try to solve for y unless there is a proportional relationship. Question number 10 does not show a proportional relationship for that table. You can see here in blue that all of these unit rates are different. And because those unit rates are not equivalent, then you do not have a proportional relationship. For number 11, you're going to need to pause the video and take a look at the work here. So we've got lots of stuff going on here. First of all, the table includes fractions. So what I tried to do is show you from the table the different work that I used to get to each of those ratios. There is a common rate here of 1:3 or 1/3 to 1. And you can see that work here throughout this page. I know that there's a lot here. So like I said, you're going to want to pause the video while you're copying this. Each of these ratios can be simplified to the same thing. So you can see my work here to do that, to show you that simplifying. And then over here on the far right side, or I'm sorry, far left side of the paper, you can see here's where I solved for y, down here at the bottom. So I wanted to know what is the value of y when x is 10. So I took my unit rate of 1:3 and I set that equal to y over 10. So my y value is 1. My x value is 3. I want to know what is the y number when x is 10. And then I solve that like I did any other equation where I multiplied both sides by that 10. And in doing that, y equals 10/3. And 10/3 is the same as 3 1/3. Okay, if you're not sure how I got that, then put a little star next to this one and be sure to come ask me. Number 12. The ratio of the height of the building to the number of floors is 135 feet to 9 floors. That is a unit rate of 15 feet per floor. In other words, each floor of that building is 15 feet tall. The building would be 225 feet tall if it had 15 floors. And you can see how I solved the equation, or that proportion, 15:1 equals y over 15, where the top number represents the number of feet and the bottom number represents the number of floors. Number 11. These two tables do show the same proportional relationship. Both tables have a unit rate of 2 25/100 to 1. And we divide each ratio y divided by x to prove that those unit rates are the same. Question 15. Make sure that you realize that this is a select all that apply. In other words, there could be more than one correct answer. All right, so here for number 15, you can see my work and my answers. The first thing I did is I created a set of ratios, y to x, for each of those values in the table. And since they gave us decimals, I went ahead and used my calculator to show you that each of those will transfer into the unit rate of 125 thousandths for y and when x is 1. Now, 125 thousandths to 1 is another complex fraction because 125 thousandths is actually another name for the fraction 1/8. You can see that here on the right side of your page. And then I went ahead, because this shows a proportional relationship, I went ahead and looked at the second answer that says when x is 20, y is 2 and 55 hundredths, this one right here. And I solved that proportion substituting the 20 in place of the x, so at the bottom, when y is what we're looking for. And when I did that, what I found is that y is actually 2 and 5/10, not 2 and 55 hundredths. So this is not a correct answer. Okay. And then the third answer is also not correct because the ratios that relate those pairs of x and y is actually not equivalent to 8. It's equivalent to 1/8, which is the third answer, or the fourth answer down here. So it is a proportional relationship, and the unit rate is 1/8, and you can see that work right here to get that 1/8. Turn that decimal into a fraction, and then simplify that fraction. All right, so hopefully you've noted some questions that you still have, and you are going to be ready to ask those before you get to work on your assignment. Please make sure you have all of your notes, all examples, and all the work that goes with those examples written in your book.